and my team. I probably couldn't have a better speakers in front of me, because you actually highlight what we're going to talk about, which is the images and how we capture things. I'm going to talk about autonomous sensors and a project that we're quite proud of. Inspections. A lot of the inspections are about capturing images. But most of the people that do this is most into helicopters and drones. And they're not really happy about cameras. And you have the guys that has been talking, they interpret the images, which is also very important, but they still are not really interested in capturing, taking good photos. So we say, this is a missing part. We did a crash course 3 years ago with eSmart Systems, building drones, doing imaging systems, and we realized that it's one thing to fly a drone. That's hard, especially when you're long distance flying. And it's even harder to actually take good pictures when you're jumping up and down. So we say, this is the really hard part of autonomous inspection, long distance, beyond line of sight. We should be able to connect the camera to any carrier, including manned helicopters or robots. Any application, of course, you have to adapt it with software. But this camera system, precision, detect what you want to see, and adapt it for the application. And you also provide context. The interesting thing, we came up with very, very nice images, but it was very hard for the AI to understand what it was seeing because it didn't understand the context. So you probably also need several field of views when you actually take not one image, but the context too. A few words about autonomous flight. What is it? In some areas, you will say, all right, go into the forest and look for something. But usually you have a plan, and then you have situational decisions. Is there something wrong? Am I going to collide with something that should not be there? Why do we do it? Because it's dull, dirty, distant, difficult, dangerous. At least one of them. What is needed? In terms of the inspections we do, you need actually a very, very good 3D planning in advance. You need communication. You need detection and handling of exceptions. And you need actually to take good photos, because that's why you're there, usually. There are two difficult things. Detection and handling or detection of exceptions, and do something about it. And the imaging. We are not supposed to be good at detecting or flying autonomously at all, but we are supposed to be good at imaging. So there's an area that we define as autonomous imaging. That is a subset of autonomous flight. And we also work with helicopters and other manned crafts. There's a reason why newspapers hire professional photographers, and there's also professional photographers here, I suppose. It's not a kid 16 years old with an iPhone. It is actually difficult. And what we try to do, that is putting autonomy in the camera. Show you why. 70 kilometers an hour. For those of you that is known in Bergen, you will see that it's very close to Bergen. We are now flying about 70 kilometers an hour. And let's say this is a drone, and this is simulated though, with data from Høydedata. Excellent excellent site, by the way. By the time you fly by, you're supposed to actually capture quite a lot of images. Helicopter pilot or the camera operators on the helicopters can do it, but that's a dangerous job. But you cannot do this remote with a drone. There's no way you can do it. We believe that being able to do this with computers is the way of the future. So, what does it look like? Something like this. Not done in real life, but done on the lab. We detect the pylon, and we get close and we take the close-up images. And by the way, we do not do the analysis afterwards, finding cracks. Other companies like Cognite or eSmart and other companies are excellent doing those things. We're not in that business. But this thing, finding something at a distance without manual intervention and taking the detailed images and ensure that these are sharp and good enough, that is actually a complete business in itself. Why would you like to do it? Because you want to separate capturing images from flying drones. And there's also an issue about that because you want to have a drone approved and with the autonomy, but you don't want to talk too much about how we actually capture image. If you mix those two things, that you're going to fly close to a thing, etc., and have rules for that, is another topic to have that one approved. We can operate at safer distances because we have much more control with the camera. And we believe one thing is very important, because with this kind of image made by a computer for computers, not by a human for humans, but by a computer for computers, that also makes sense because we want to make images that can be read by computers. And, of course, the same platform can be used for robots, helicopters. The autonomy, or the architecture for this. Flight controller, there's a computer on board, we might call it mission controller. There's a 3D planning, it's 3D planning for the payload, and at times we might also get data from the drone itself so that we can verify that it's actually the correct thing we are looking at. So, what's next? What do we do? We want to fly far, and we want to have autonomous drones that fly there. And let's say we want to fly fast because we're going far, 70 kilometers an hour. We take images, and we add communication because we actually, at least in Norway, we are supposed to be aware of where the machine is at any instance or any point of time. And we want to do this, let's say, up to 100 kilometers. We proposed this to a company called StartNet and brought with us some friends, and they said, cool, let's do it. So we do the autonomous sensors. Maritime Robotics have the drone you see upstairs. There's a 3D planning tool that is not really decided yet, but it's a very important thing because you're going to do close-up planning. We're not sure who's going to do that yet. Airlift Solutions is actually really good at the regulatory stuff, and we need that. And they also do have helicopters available. And as you heard earlier today, Telenor is also there. It's quite important for us to have some kind of communication link and predictable. So it's very cool that Telenor now say that, yes, we want to be able to tell you where in 3D the mobile coverage. And that is the part of this project. And thank you to StartNet and BKK. They actually give us the domain competence. This is the planned project. We all agree that this is going to be done. Cool stuff. And what are we going to make? Better images. How do we do it? We think that, or we believe that the most important thing is to have a context. So you can have a wide view of what the drone see, and you have at least one telelens that will, or that can be able to make detailed images of whatever you wanted to do. This is the concept. This is about what we're going to deliver. So, when will it be available? We assume that it will be available for trials next summer. And we also do believe that this kind of technology will make drones much easier to make autonomous, because the way you plan and execute missions becomes safer. That's basically it. Thank you.